Good day everyone, I am Hock Seng and today I would like to do my minor presentation on water reticulation, erosion and sedimentation, and cost and estimation. In water reticulation department, Calvin Oscar and Nadia Hock are in charge members. What is water reticulation? Water reticulation is the process of supplying the proper amount of clean water for any needs. Water reticulation system consists of a network of pumps, pipes, and water tanks that are designed to distribute water to domestic areas. In this project, the goal is to provide a clean and sanitary water to be supplied to a light industry and work quarter. There are 6 objectives such as to determine the water demand of the allocated area, determine flow rate in pipe, determine the piping size, determine the height of storage water tank, design a suitable water tank capacity to fulfill the demand, and lastly, fulfill the suitable residual pressure. This is our proposed layout for water demand design. The region is separated into northern and southern so that the water pressure does not exceed the limits. There are 25 nodes, 31 pipes, and 8 loops. All the loops are closed loop because it is more efficient than open loop. Since the design keeps the water enclosed inside the system, closed loop systems do not require additional water periodically to replace that loss from evaporation. This is our proposed layout for fire hydrant design. These two are the guidelines for design water tank and pipe. Based on MWA and SPAN, there are some criteria we should follow, which are velocity must less than 2 meter per second, residual pressure head must less than 30 meter, unit head loss must less than 2 meter per kilometer. This is the water demand based on SPAN. Different type of premises has different water demand. Below figure is fire risk class based on MWA. Based on our project types, we will choose the class C risk. This is example of water demand calculation. There are two important things we need to know, which are the total water demand for node in fire flow and also peak flow. This is the grounded water tank design at northern zone, and the criteria such as material, shape, volume is provided. This is the elevated water tank used at southern zone, and the criteria such as material, shape, diameter, volume is provided. The figures show the location of those two types of water tank. Northern zone using grounded water tank, while southern zone using elevated water tank. In this task, we are going to use the aid of software called EPANET. It is used to design a suitable plan to provide basic water demand needed for the project. There are some examples of EPANET peak flow shown in the figure. These are the peak flow analysis using Microsoft Excel, and we check the pressure head and all the results are okay, so installation of pump is not required. In conclusion, we have separated the region into two parts. In the design, it was planned to allow a manageable residual pressure head and velocity to be supplied to all the light industry in the region. Northern zone used grounded water tank, while southern zone used elevated water tank. Hereby, I would like to appreciate the contributions from Calvin Oscar and Nadia Hock. In Erosion and Sedimentation Department, Adam Daniel and Shakir are the in-charge members. What is erosion and sedimentation? Erosion is the transport by wind, water, sediment, and rock fragments produced by the weathering of geological features. Sedimentation occurs when eroded materials that is being transported by water settles up the water column onto the surface as the slow water flow. These processes will give adverse effects on the water quality due to the siltation. There are 8 recommended principles: minimizing soil erosion, preserving topsoil and other assets, access routes and site management, drainage control and runoff management, earthworks and erosion control, sediment prevention and control, soil stabilization, site maintenance. This is the final proposed SCP design. We have divided into 6 areas, and yellow color indicates sediment basin, pink color indicates wash bay, and dashed green line indicates silt fence. Runoff management BMPS. Runoff management is a way to control any movement, volume, or velocity of the stormwater from damaging the site through the erosion. Management Manual for Malaysia (MASMA) that published by the Department of Irrigation and Drainage (DID) Malaysia is the ultimate guideline for our erosion and sediment control. One of the design criteria is estimating rainfall data and the site's ground condition, as it is more important to ensure that the sediment basin and temporary drainage can withstand the highest peak discharge on the site. Three parameters in rainfall estimation, which are average recurrence interval (ARI), time of concentration (TC), and average rainfall intensity. These are the calculations of time of concentration, average rainfall intensity, and peak flow. Establishing an excellent temporary drainage system in development sites is to direct runoff water so that it does not run across the disturbed and undisturbed areas. We use the best hydraulic section of trapezoidal. We input the data into the formula to calculate flow rate and velocity. The flow rate is greater than the requirements, so it is adequate. A sediment basin is a structure usually formed from excavating or building an embankment across a waterway or other suitable location to collect and store the sediment from sites cleared or during the construction for extended periods before re-establishing permanent vegetation and building permanent drainage structures. The basin is a temporary measure that will be regularly maintained until the site area is completely protected from erosion and until a permanent detention basin or water quality control structure is built. These are the overall basin's dimension and trapping efficiency. Trapping efficiency 90% is higher, and the sediment storage zone for the basin is 1062.81. Hence, the provided sediment basins can contain the settled sediment. There are other sediment control (BMPS), which are wash bay, silk fence, and hydro-seeding. Wash bay is usually located at stabilized construction entrance or exit. Every machinery entering the site must go through the wash bay to make sure that the cleanness of machinery. Silk fence is used to retain the sediments from small bay areas and caters to small overland sheet flow. Hydro-seeding is a planting process that stabilizes and protects the soil surface from rainfall and runoff from disturbed areas. In conclusion, all the designs for the ESCP requirement are satisfactory for the proposed project according to MASMA. The sediment basin design is capable with higher trapping efficiency 90%, wash bay, and silk fence also built to reduce the risk and off-site sedimentation. Hereby, I would like to appreciate the contributions from Ada Daniel and Shakil. In Cost and Estimation Department, Lydia and Vivian are the in-charge members. Costing is the process of figuring out how much a building project will ultimately cost by considering all factors, including labor, materials, equipment prices, and taxes. Estimation is the process of determining the cost of building projects. The goal is to provide an extensive list of all the required materials and machinery to come up an overall project cost. There are 8 earthwork specifications that have been used, which are general, site clearing, preservation of existing trees, removal of topsoil, excavation, filling, slope protection, inspection. These are the project plan. We divided into 2 phases, and the duration of each process is shown in the plan. This is the project timeline. We take almost 1.5 years to complete the project. There are 6 types of equipment might be used, and we need to determine the higher production rate for each category and select the most suitable. This is an example of net production rate calculation. After we obtain the higher production rate, these other equipment have been selected. This is our Phase 1 and Phase 2 cost estimation. Area of Phase 2 is higher than Phase 1, so cost also will be higher. Value engineering is used to solve issues, find and remove unnecessary expenditures, and enhance the functionality and quality. The value engineering process is a set of systematic actions designed to maximize initial and long-term investment by finding the highest attainable value at the lowest achievable cost. The purpose of value engineering is to guarantee that the client obtains the full benefit for all the costs of project. This is the implementation from before to after value engineering. It has significant reduction in cut and fill volume. Based on our new proposed level and new cut and fill volume, this is our phase 1 and phase 2 cost estimation in second trial. These are the references used in the cost and estimation. In conclusion, we have estimated the total cost of both initial and new proposed level from site clearing, excavation of topsoil, cut and fill, transportation and compaction. We have achieved around 40% of overall cost reduction with an initial cost of 11.75 million and final cost 6.58 million. That's all from my presentations. Thank you.